acceleration, all right, if you had to explain what that was to a little kid, like a third grader or something, could you do it? Okay, Ty, what would you say?
I would say it's like, how to use a car as an example. I'd say, like, if you step on the gas, how fast you go from 0 to 40.
Okay, good. All right, that is definitely part of it. We're going to add some stuff to that today. Okay, acceleration. Here's the definition. And the definition is kind of in equation form. Kinematics Notes Part 2 is the handout that we're on. We will shorten this into symbols here in a second, okay? Change in velocity over time. Here's how we shorten it if we don't want to write all that out. We simply have lowercase a for acceleration. Capital A is reserved for area, by the way. Okay. Lowercase a, acceleration. And we got delta V over T. In science, in math, anytime a change in is always the final value minus the initial. Okay, and then we divide by the time. So here's an easy example. You don't necessarily have to write this down, but you can. Let's say we've got a car, it's going 50, and now it's going 70. Okay, what is the delta V, the change in velocity? Okay, you always do the final minus the initial. Okay, so it's not 50 minus 70, it's 70 minus 50, which is a positive 20. Then we divide by the time it took, and we get 2. Okay, the acceleration of this little example would be 2 miles per hour per second. Okay, question?
What if you flip it and you go from 70 to 50?
Okay, then it will come out to be negative 2. So if the car was going 70, it slows to 50. Now we have an acceleration of negative 2 miles per hour per second. Now here's the meaning of the 2. The 2 means that every 1 second that goes by, the speed is changing by 2 miles per hour. Okay? All right. So here's some little animations. Quiz yourself, see if you can get these right. Calculate the acceleration of this vehicle. Would that be a fun car to be in? It would be terrifying. That is a lot of acceleration, and that's a lot of speed. Okay, so, all right, anybody, what's the acceleration of this vehicle? Okay, go ahead. What is it? It's 10. It's 10 miles per hour per second. We'll do more with units in a minute, but what that means is every 1 second, the speed is increasing by 10. Okay? And that would be an intense vehicle to be in. That's a lot of acceleration right there. Okay. All right. How about this one? Okay, let's go to our little box here. I'm not going to call you guys by your real names today because I'm filming this, so I'm just going to call everybody like Joe. What should our female name be? Okay, all right, what do we got?
5 miles per hour.
Okay, good. T, all right, it is 5 miles per hour per second. Okay, so every 1 second, 5 miles per hour increase. Okay, does that kind of make sense? All right, you can think of acceleration as the speed of the speed. Okay, how quickly the speed is changing. Notice that 50 and 100 are not our answers. Those are speeds, they're not accelerations. They have to do with our accelerations. Okay, but here's how you want to think of it. If these little needles right here, okay, let's say those little needles had little speedometers on them that measured how fast they moved. Okay, what would we call those little instruments that measured the speed of the speed?
Accelerometer.
Oh, good. Yeah, accelerometers. And those exist. Okay, those aren't a made up thing. Your phones have accelerometers in them. All right, a lot of cars now have accelerometers in them. Your insurance companies send you these creepy little boxes and you can put them in your car and it says how safe a driver you are. Does anybody have those? A lot of insurances have them now, and then your parents can like look up the data and see like your acceleration. Or Life 360, what do you think that does? That measures your acceleration too. Okay, I'm pretty sure. Okay, all right, see if you can answer this question with your neighbors. That means you gotta talk to each other or somebody around you. See if you can brainstorm. Okay, go.
The gas pedal together. Like brake control But then there's also the brake because it causes the car to decelerate, but acceleration is all. Yeah.
Okay, all right, let's see what you guys have to say. Miss T right here. Okay, well, give me one.
Gas pedal.
Okay, the gas pedal, sometimes called the what?
Accelerator.
There you go, the accelerator, right? Okay, good. Okay, absent. Okay, D.
The brake or the decelerator.
Okay, the brake, right? Okay, braking is accelerating, is that right? That can't be true. It is. Braking is now accelerating. Okay? Alright, mind blown maybe. We gotta get that in our heads that slowing down is counts as acceleration. Now we might call it what? Deceleration. Okay, we might say that word sometimes. Okay? But any change in velocity is acceleration. That's a really big deal. Okay? Alright, those two. Okay? Alright, what else we got? Okay. Alright. T? It gets kind of tricky, doesn't it? Go ahead. Okay, what gear you're in, that's a good one, okay? Because can you slow down or speed up based on your gears?
Yeah.
We could say there are 4, okay? You might have transmission right there. That is a direct control that would count, okay? All right. Okay, what else?
So since velocity is like also changes like direction, could it be a steering wheel? 'Cause if you're
Oh,
steering-
nice, okay. Look at that. Steering is now accelerating. That is correct to say that steering is accelerating. Okay, because changing your velocity, remember velocity is a vector. These change the magnitude of your velocity vector. Okay, the number on your speedometer is changed by these. Your direction is changed by this. Now, do we have a way of measuring this change in our cars?
Some of them have like direction.
Yeah, some of them have a little digital meter up here, okay, and they'll tell you the direction change as you move, okay, but not really something we look at all the time. All right, all of these are accelerating. Okay, next we're going to talk about units for acceleration. Okay, and I'm actually going to do this on the board because it's just easier. All right, you got the board over here. Okay, so first of all, let's start out with this. Acceleration is delta V over T. Okay, we got that down. Let's get more specific. Okay, a delta is always a final minus an initial. And you're going to see those little I's and F's a lot in this class. They mean final initial. And we got a time down here. We want to know the units for acceleration. That's what we're doing here. Okay, so what's the unit for velocity? We should know this. What do we got?
Meters per second.
Okay, meters per second minus meters per second over seconds for our time. Okay, and we're getting to the unit of acceleration. Now if I take 50 miles per hour or 50 meters per second and I subtract another speed, what does the unit of that answer come out in? Still meters per second, okay? So I end up getting meters per second over seconds. Okay, and now I got a fraction in a fraction. What should I do? Cry? Just like play video games on my phone and give up? Go home and take a nap? You guys are like, that sounds pretty good. Okay, so you should do what your math teacher taught you anytime you have a fraction in a fraction. And what did they teach you to do? Okay, what do we got? It is canceling. Yeah, we will be doing some canceling, but they call it copy dot flip. Does that ring a bell?
Yeah.
Copy dot flip?
Yeah.
Okay, here's how we copy dot flip. First of all, we turn this into a fraction by dividing by 1. And now you can see that I have a clear fraction. Okay, here's my big line. And I got another fraction. It's called a compound fraction. I think that's what they call it. Okay? All right, so what you do is you copy. And you always copy the top one, not the bottom one. Okay, then instead of doing that, you put a dot, a multiplication symbol. And then you flip. You do that. So I have 1 over s. And then you just multiply. Okay, so meters times 1 is meters. Seconds times seconds.
Seconds squared.
Is it 2s or seconds squared?
Oh, second squared.
It is seconds squared. Okay? And that is the unit, the SI unit for acceleration that we will use all the time. Now it takes a little getting used to because it's got a squared in it, it's a fraction. Okay, so it takes a little time to get used to what it is and what it actually means. Okay? Alright, little math ninja move that you're going to need in this class in your back pocket, compound fractions. Okay, so units of acceleration. Let's talk about this for a second. This goes back to the steering wheel part, the change in direction. So we've got a highway here, and let's say we got some ramp, and we got a car, it's going 70, but let's say it just stays at 70, okay? It's not gonna increase its speed, okay? And it's just gonna do that. All right, now let's go over here, and let's calculate the acceleration. Okay, so if we use this equation, you don't have to put this on your papers. Okay, I'm just going to write it on the board. Okay, what's my initial velocity?
70.
What's my final velocity?
70.
Okay, so I'd have acceleration is 70 minus 70. Let's say that takes 15 seconds to go around that part of the highway, whatever. Okay, what's the answer to this fraction? 0 over 15 equals 0 meters per second squared. Okay? Alright, now, that's wrong. Okay, we cannot use this equation for changes in direction. Okay, we can only use this equation for changes in what? Starts with an M. Magnitude or speed. Okay? Dealing with change in direction, we will deal with that in the winter, okay? All right, we'll deal with that when we talk about something fun called centripetal acceleration. Okay, dealing with changes in direction does not involve this equation. All right, so we get that out of the way. Now, kind of for now, since we're not dealing with it, okay, let's just think of it like this, all right? If somebody steps on the gas really hard, do you feel that, like, in your body? Like, can you feel it? Okay, if someone brakes really hard, do you feel that? Your body has a sense of danger from that. All right, that is the feeling of acceleration and deceleration. Okay, now, if you go around a curve, even though that equation would say 0, if you go around a curve too fast in Tibet Canyon, do you feel that danger? Your body knows that danger. Okay, physics is already programmed into you. Okay, that's the feeling of centripetal acceleration, which is really fun to talk about. Things going on curve paths, but we stay in one dimension for a while here. Okay? All right. Okay, we're going to practice calculating acceleration. And we've got a motorcycle video here. Okay, let's watch this little video. Do not try this. Some data for you. Okay, I want you to calculate the acceleration given this and this. We're going to stay in miles per hour because it's convenient. Okay, and that's what our speedometer is reading it. Okay, try that out. I'm going to call on some of you to give me an answer. Definitely going to need our calculators today.
Convert the miles per hour into meters per second?
Normally, yes. Normally what we would do is we convert these first, and then we'd end up in meters per second squared for our answer, but that's kind of a pain, so we're not going to do that for any of these examples. We're going to end up in kind of a weird unit that we'll talk about. Okay, let's go back to M in the back. What do you get? I'm calling you guys by your first letter since this is going on YouTube.
8.9 miles per hour.
Okay. We're going to do that. We're going to get 8.8, just like she said. Okay, now the unit of this is miles per hour per second. The other way to write it is like this. Miles per hour over seconds. Okay? All right, my marker's kind of dead. But what it means is every 1 second, what is our speedometer increasing by?
8.8.
8.8. That's what it means. And that would be a really intense acceleration, because you can see from the video what's going on there. Okay, motorcycle number 2 in your notes. Okay, that was just a snippet of the same video. It's that long, and then here's some data, 45 to 95 in 2.9 seconds. Okay, let's go to C over here. CH.
I got 17.24.
Okay. You guys agree?
Yeah.
All right, delta V over T. We gotta do it in this order, not the reverse. Always final minus initial. Okay, and we're gonna get 17 and change on that. Okay, I rounded mine. And much higher acceleration for this part. Okay, this is the part where we like did a wheelie. Again, don't try this. Okay? Here's a graph of the entire 25-second video. Okay? And so it shows the speed at different times, just from reading the speedometer and watching the video. Okay, this is really, really important to have in your notes, how to deal with a velocity time graph. Okay, let's check it out. First of all, we already know this. Already got that in our notes. How do we apply it to this graph? Okay, how we apply it is slope. What did your math teacher teach you about slope?
Rise up.
Anytime we deal with a graph, you want to go back to this fact, okay? And thinking about what's the slope mean. You're starting to realize that. So, rise. Okay, rise is what? Change in velocity. Okay, run. Right here. Run is change in time. So the slope of any VT graph always gives you acceleration. Okay, you want that in your notes somewhere. The slope of any VT graph always gets you acceleration. And that, by the way, is a little calculus. Okay. Here's what we did in motorcycle 1. We calculated an average acceleration, okay? We said 220 minus 0, that's our rise. And the run was the whole time period of 25 seconds, okay? Now, you notice the slope of the blue line, is it constant? It's changing, okay? So for the whole video, the average acceleration is 8.8. Is that right, 8.8? Okay? All right, now we can add other lines on here. I think this is the one you just calculated, okay? 17.7. You notice the slope is really steep for this little part. So that would be an acceleration for a little time period right there, okay? Not for the whole thing. Okay, question?
I noticed that the purple line exactly matches the blue line on a part of the graph.
Yes, that's right, okay? It matches this little part, okay? And sometimes we'll have a curved line here, and then you would be drawing tangents to the curve, okay? And that's just a little bit more calculus, all right? In calculus, by the way, they call this stuff derivatives, okay? Some of you are going to get to that this year and next year. Okay, what else?
Wait, so why wouldn't you just use the same accelerations, like the same slope line?
Okay,
It's like
well,
if
it
the
just
line
depends on
was-
what I want. So if I want the whole acceleration for the whole video, I would do motorcycle 1. But if I want the acceleration just for that little wheelie part that he did, then I would just use this little time period. So it just depends on what we're trying to find. All right, let's do some more examples. Okay, motorcycle 3.
What's
Oh,
the time?
speeds are up here, 150 to 200.
What's the time?
Oh, yeah, you need that, don't you? Okay, there you go. Okay, let's go to C over here.
8.16 miles per hour.
Very nice. Okay. this one comes out close to the average that we calculated in the first one. Okay, now, looking at this, this is about the amount of work you need to show on a worksheet or a quiz or a test, okay? If you look at our steps to solving physics problems, we've got data listed. I did that for you in this case, okay? We've got an equation without numbers plugged into it. We've got an equation with numbers, and then we've got answer and units, okay? Keep that in mind as we're doing these. Okay, motorcycle 4. Okay, don't say the answer out loud. There you go. Okay, let's go to R up front here.
There's no change in acceleration.
Okay, good. So what's the answer?
0.
Okay, 0. There's no change in the. There's no change in the velocity or the speed, which means 0 acceleration. And there is also no change in the acceleration as well, because it's 0 the whole time. Okay, the math proves it. It was going 220 to finish the final, and it started at 220. Okay, constant velocity. All right, divide by 15, you get 0. We need to know this. You can be going really, really fast and have 0 acceleration. Okay? I want you guys to go home and test your parents on this a little bit. Okay? Teach them a little bit of physics. So next time you're riding in the car on I-70 back here, okay? See if they know the difference between speed and velocity. You're going 75 because your parents don't speed, right? They go the speed limit all the time. Okay, 75. And you say, Mom, how fast are we going? What's she going to say? 75, which is the correct answer. Okay, and then you ask your mom or your dad, what is our velocity, Mom and Dad? What are they going to say? Are they going to know? They might. Okay, what would be the correct answer to the velocity question?
75 heading some direction.
75, and then they'd have to attach a direction. Okay? All right, then the third question you ask them, okay, you're going constant speed of 75. You ask them, what is our acceleration, Mom and Dad? Okay, what's the answer?
It depends on the change in
0. The answer is 0. We're going constant speed down the highway. Okay? All right, see if they know that stuff, and then you can teach them. If you teach it to them, then it's going to stick in your own brain. Okay, but I once had a kid get grounded over this little assignment. So don't get mouthy with your parents and start mouthing off and saying how much you know. Okay? Kid got in an argument with his dad, and he's like, yeah, Dad, you don't even know. Okay, and got kind of mouthy, and then, yeah, got grounded. So don't do that. All right, last one. That was 11 seconds. Okay, IQ in the back, what do we got?
Not negative, none. What's going on?
Can it be negative?
Yes.
Absolutely, okay. Because we're gonna subtract it in this way. Final minus initial, always, always, always. And you're gonna get a negative 9.1 miles per hour per second. Okay? All right, now what does the negative sign mean? Okay, in this case, it means that the thing is slowing down, but we gotta be really careful with this. Okay, negative does not always mean slowing down. Okay, so for now, last thing I'm gonna say about this. Okay, let's say the velocity we've been calling positive into the screen is positive, right? So for acceleration to slow down, we need the acceleration to be in the other direction. Acceleration is a vector as well. Okay, so if velocity is positive and acceleration is negative, what happens to the object?
It slows down.
It slows down. Okay, now here's the other side of it. Let's say the thing's going this way, and we call this positive, or we call this negative. So let's say it has a negative velocity in this direction. That doesn't necessarily mean it's going backwards, by the way. It just means it's going down the road this way. To slow down, what would your acceleration have to be? Positive. It'd have to be in that direction. Okay, now for now, if that's kind of a little bit like, okay, all right, we're going to do a lot more with that, so don't worry too much about that. Okay? All right, that's it. That's basic acceleration stuff.